Hello everyone and welcome to the second episode of CPP Next. In this episode we will talk about a new feature we got in C++20, the smart pointers for overwrite. This feature is not unique for the shared pointer, but in this episode I would like to cover just the shared pointer because it's more interesting and has more little corners. So if we will understand what shared pointer does, to understand what unique pointer does, it's really easy. To understand why we need the new functionality of the override for the shared pointer, we need to remind ourselves how the shared pointer works and why it's almost always better to use make shared and not just allocate the shared pointer with its constructor. Let's learn from an example. Let's say that we have a struct S that has two integers, x and y. And let's say we want to allocate a shared pointer out of this struct. If we want to use a constructor method for the shared pointer, we need to provide it with a pointer to S. Here we are using new and allocating S with initialization of 1 and 2. But what happens when you do that? What happens in the memory? How the shared pointer is actually built? Because we are using a shared pointer constructor, we first had to allocate the data section. Or basically, we had to ask the OS, please allocate memory in the size of S. Then the constructor allocates another memory section for the control. The control section contains the atomic counter and the pointer to the data itself. Because we have allocated two different chunks of memory, it is more problematic performance-wise because we had to ask the OS to do it twice. But even in runtime, we might have a performance problem because we allocated this memory twice. We will have to hop between those memory chunks. We are accessing the data through the control, and then you basically will need to go to another section in the memory, which may cause cache invalidation and worse performance overall. Now let's look at the difference. What will happen if we will use make shared instead of the regular constructor? As you can see, the only difference is that we are using make shared of S with 1 and 2. When make shared is used, we allocate enough memory for control and data. This memory is continuous. That means that we ask the OS to allocate only once, which is a performance boost by itself. We also don't need to hop between different memory regions because we're in the same region. And we might even fit in L1 cache, which means more performance boost altogether. Now, after we remembered why we should use make shared, let's explore make shared for override. The problem with make shared is that we have to call the constructor and initialize the data. Sometimes, when we know that we will immediately overwrite the data or we will never access the data before we will overwrite, we can actually skip this step and save some precious nanoseconds. We can do that by default initializing the object, and that is exactly what make shared for override does. Let's explore the difference in performance between those two. We will look at an array of points. Yes, we got that in C++20 as well, so stay tuned for a different episode where I will talk about those features as well. Now, we will write a simple function that will create an array of points and fill them. As you can see, because the regular make shared had to call initialization of the data twice, it got performance hit compared to the make shared for overwrite. Actually, make shared for overwrite is 1.7 faster than the regular make shared in this case. So in conclusion, use this great tool when you know that you don't need the double initialization and boost your performance. Thank you for watching and see you in the next episodes.